Good afternoon. How are you, Marion County students? It's Mrs. Suter again, and I'm here to show you a couple more projects. These are really kind of summer fun projects. I'm wearing my summer get-up. Today we're going to talk about trajectory and a little bit of the science behind trajectory. And trajectory is not a difficult subject at all. Actually, people think that it's a hard word, but it's actually pretty easy. And you guys already know a lot about it that you did not probably realize you did. But trajectory is simply the path that an object takes when it flies through the air. So you guys already know a lot about that from playing soccer and basketball and baseball, and if you play football or tennis, or if you play pool or golf. These are all things that use trajectory to get the ball to go where you want it to go. And that's very simple what it is. It's a path that the ball takes to get from one place to another. So today is what we're going to do, and we're going to talk about trajectory and a little bit of the physics of trajectory, and then we're going to do two projects that are fun to play with. So these are going to be things that you can play with in the house or outside of the house and have a little fun practicing with trajectory. So I am going to start sharing my presentation with you, and we will talk about the physics of trajectory. Okay, so again, trajectory is very simply the path that a projectile, which is an object, takes when it flies through the air, when it's launched. Okay, and we call that object that is flying through the air, we call it a projectile. Okay, so this is projectile, this is the trajectory. Okay, so let's talk a little bit about that. Throughout history, men and women and people have been using trajectory, the laws of physics, to throw objects. Now, even at the time of cavemen, and they made their spears, they would throw the spear at an animal to kill it, and that's how they got their dinner. So they had to be very precise about how they threw it so that it landed where they needed it to land to kill whatever animal that they were hunting. I don't know, saber-toothed tiger, I'm not really sure. But they had to know how to launch it so that it would land exactly where they wanted it to kill the animal that they were having for dinner that night. Now, if they missed, they'd go hungry. So understanding how to throw something so that it landed where you wanted to was really important because that's how you got your food. Also, they used it to protect themselves from animals. So throwing objects has been around since the time of cavemen. Now today, we usually more use trajectory when we think about sports and throwing things for sports. We don't use it as much to kill, but we do still, some people do go bow hunting using the bow and arrow, and so they have to know a lot about trajectory as well. Now, after the cavemen and the spear, we also had the Native Americans or the Indians and the bow and arrow. We also had what they called an atlatl. An atlatl was during the Stone Age time, and it was a flexible dart that they would throw or that they could shoot, and it would kill a deer about 40 meters away. So they had to be very, again, specific on how did they get that dart to land where they needed it to so that it would kill that deer so they would have dinner that night. And even in Australia, the Aborigine people, they use boomerangs to do the same kind of thing. They would throw the boomerang, it would hit an animal, knock it out so that they could kill it for dinner. So throughout Europe and Africa, they also use the boomerang as well. So there are lots of, and you can even read more at this newscientist.com article about the history of projectiles and how we have perfected the use of them over the ages. Now, about 2,000 years ago in Greece, the ancient Greeks developed all kinds of weapons that they used in battle that would throw projectiles. And they became so good at it, they actually perfected it. And they named these devices ranged weapons. So they could actually know where the projectile was going to land, how much force they needed. And they created these very large, some of them were very large apparatuses that would launch a cannonball or an arrow or something to hit a wall to knock it down or to in battle. Now, there were lots of different kinds. This right here that you're looking at is called a caraballista, and it was very big, very, very large. Here's a person, and here's the caraballista. They would bring these into battle. It took a lot of effort to move them to where they needed them to, but they did so much damage that it was worth their effort to haul these out to use during battle. But they also had things like catapults, ballistas, trebuchets, gastrophetes, oxybeles, that's how you say that, and onager, and then a Scorpio. These were all different ranged weapons that they invented. So over here you can see some of the pictures of them. Some of them were handheld, and some of them were very, very large. This right here is a ballista, and we're going to be looking at the ballista, and I built one here so that we can take a look at it. So these are all different ones, even throwing the javelin, which we do for sport now in track and field, but these were all things that the ancient Greeks used to, or in battle, and to kill animals so that they could get things. So some of them used arrows, some of them used cannonballs, and some of them were more like a spear. And this right here is the trebuchet. Okay. All right. So, first of all, how do all of these things work? Well, it's really actually very simple the way they work. They create a force through bending or twisting something out of its normal shape. So right here, if you look at the bow and arrow, this right here is the bow, and this is usually a wooden or plastic piece, and it's built so that it's supposed to bend. So when you pull back this tight string here, it'll bend the bow, right? So they're pulling back on that string to bend the bow in. Now the bow wants to go back to its normal position. So when you release the string, the bow will snap back to its original position, and creating a force that will push this arrow off. And that force is called torsion. So when you bend something out of its original shape, then it snaps back into its original shape. That's how you get that force. So, and like I said, that force is called torsion. Now, you can also get it, besides just bending a bow, you can also twist string. And if you've ever twisted a rubber band and then let go, you can see it quickly untwist. You probably do this on the playground when you are in a swing, and then you twist the chains together. Then when you let go, they want to go back to the original position, and so they start spinning you with a lot of force around and around. And that's the other way. So you can bend something out of shape, like a piece of wood or plastic, or you can create the same effect by twisting together string, rope, chain, something like that. So the bow and arrow works with the bending of a piece of plastic or wood, and the ballista runs from twisting string. So we're going to look at both of these, and we're going to see. Now, if you want it to swing a lot, you're going to want to twist it a lot. If you want it to just swing a little bit, then you only twist it a little bit. Okay, so the more force you put on the bending of the bow or the twisting of the string, the more force you're going to get, and therefore the longer the throw is going to be. If you want a little bit, you're going to not bend it as much out of shape or not twist it as much. Okay, so let's look at a couple of things that we're going to be building. One of them I built, so I'm going to quit sharing my screen for a minute. Okay. Now we're going to be using the idea of bending to create a catapult, because I'm going to be bending back this wooden craft stick to create a force. So when I let go, it flips back to its original position, which creates a force here. And that force, that torsion, launches the object, okay, the projectile. So this is one we're going to be building. Now, one that I built that I belong to Tinker Crate, and you can see that says that right there, Tinker Crate. It is a monthly subscription that I belong to, and it comes in a box every month, and it comes with all the materials to build the project, and it comes with your information. So it has a Tinkerzine, and this is from Kiwi Co. And this mine is Tinker Crate, but there are crates for all different ages. Okay, and then it comes with the directions to how to build your ballista, and that's what this is. This is a ballista. Okay, so if you are interested in Tinker Crate, you can go online to KiwiCo, and that's where I got this. So I put the whole thing together, and the directions will tell you how, and I'm using these strings here to create that tension, to create the twisting. So in between here on these notches, I have the string going through the notches here and here, and then if I flip it on the bottom, it goes here and here. And so when I twist these knots right here, it twists this string inside. Okay, and I have these arms connected in the middle of those strings. And so when I twist these knobs and it twists those strings, it creates a lot of tension on this arm. See? And it wants to keep, if I pull it back, it wants to flip right back in shape. Over here, I did the same thing. I'm creating, you see the twisted there, bottom and top. If I twist it more and get more tension, it's going to give me more force. And you can see here that I've got a lot of force in there. Okay. Now, how I pull these arms back is from in here. I have a string through a spool, and when I pull that back, it pulls these arms, and now these arms want to fling back up. So if I let go, it's going to fling up. It creates that torsion. All right. So you see how that spool will fling back up? Well, that's how this is launched. So I have a little plastic ball, and it comes with your kit as well. When I pull back, if I pull all the way back, it's going to give me a lot of torsion, a lot of force. If I only do a little bit, it only gives me a little bit. So if I use a little bit, pops up. Oh, I hope I didn't just lose my little projectile. Lucky for me, I have a little case that I keep it in, and it fell right back in there. Now, if I want a lot of force, I'm going to pull back on the string a lot, and it'll give me so much force, it'll hit my ceiling. So, the more force I get, the more that it torsion, the more that it'll pull at it. Okay? So that's the beginning of, this is the ballista. And again, I got this from Tinker Crate at KiwiCo, and you can go online and look at those if you're interested. Okay? They run about $16 to $20 a month for however many months you want to do it. So that's just for your information. But the other thing I like about the Tinker Crate is it gives me that Tinkerzine, which gives me a lot of the science behind it, and it gives me some additional projects to do. And we'll be looking at those. Okay, now I am going to take you back into the presentation here for a few minutes so we can talk a little bit about launch angles. So again, we've talked about the trajectory. Now, in order for me to know that path and that it's going to travel, there are three things I have to know. Okay, one, I have to know how heavy the projectile is that I'm trying to launch. So if it's very heavy, I'm going to want to put in a lot of force. Okay, and if I need a lot of force, I'm going to want to bend or twist my string tighter. That gives me a lot more force. If I need a little bit of force, I'm not going to twist it as much or bend it as much. Okay, so if my projectile is very heavy, I need more force. If it's light, I need less force. The other thing I need to know is what angle I need to throw it at. So we're going to talk a little bit about what we call launch angle, and I'm going to show you some things, and then we'll talk about how that's important. So first, before we talk about launch angle, you have to know what an angle is. And you'll talk about this in math a lot, but we also use it in science. So an angle is when it's a shape that we form from two lines or rays that diverge or come off of a single point here, and they call that single point the vertex. So here's one ray coming off of this point, and here's the other one. So you can call them arms. So here's the first arm, here's the second. Now the space in the middle there, that is our angle. That would be our launch angle. And we measure launch angle with a tool called, or we measure all angle with a tool called a protractor, and which I'll show you here in just a minute. Okay, I'll show you on the screen, and then I'll show you one that I have here that I use. Okay. So we use launch angle for all kinds of projects all kinds of sports. So soccer, pool, tennis, baseball, basketball, all of those different sports, we use trajectory and launch angle to think about them. Okay, so this is a protractor here, and it is how we measure angle. So here's one of my arms coming from this vertex B. It's coming down here. And my other arm is going diverging from this B up here. And so wherever this crosses, that's where I measure the angle. So you can see it's a little beyond 70, but not as far as 80. So it's about 72 degrees. That's how much the angle is. Okay, I can do the same thing here, thinking about the ground as one of the arms and the pointing of the cannon here as the other arm. And this measure right here, which is 45 degrees, is my launch angle. Okay, so if I want a larger angle, I'm going to point it further up like this. If I want a smaller angle, I'm going to point it closer to the ground. So these angles here help me to know how far my projectile will travel. So I'm going to show you mine. I'm going to stop sharing for just a second. Here's my protractor, which Tinker Crate sent me, so I could measure my angles for my launch angles with the ballista, so I know what angle I'm using, because certain angles are better than others. Okay, all right, so I'm going to go back in here. So we're going to talk about launch angles a little bit. So here's where we talk about launch angles. This little area right here is the angle. If I aim my projectile too low, like this right here, this 30 degrees, it's going to be close to the ground and it's going to fall quicker, and so it will not go very far distance. It'll only go to about here. Now, if I aim my projectile too high up at this like 75-degree angle, it's going to spend most of its energy going up. Then when it hits that point, it's going to fall back down to the ground quickly. So I get even less of a distance with this particular launch angle. Now, if I aim it just right here at about 45 degrees, notice that the trajectory is much further. My range is a lot further. So if I do a launch angle of about 45 degrees, my projectile is going to go further. So if I don't want it to go as far, I might want to choose a 30-degree angle, 60-degree angle, or even a 75. But if I want it to go far, I need to work with that 45-degree angle. Okay, so remember, before you launch anything, you want to know the trajectory. So you're going to have to ask yourself a few questions. One, how heavy is the object I want to throw? If it's very heavy, you're going to have more force. And remember, if I want more force, that will tell me how much I need to bend my bow or my craft stick, or twist the string that I'm going to use. So twisting or bending the string, craft stick, dowel rod, whatever, gives me the force. So if I need a lot of force, I'm going to bend it or twist it a lot. If I need a little bit of force, I'm only going to bend it or twist it a little bit. All right. Now, I also want to think about how far I want it to travel. If I wanted to travel a far distance, then that's going to give me this launch angle. Not as far, maybe the 30-degree or the 60-degree launch angle. So if I have to determine the force and the launch angle to determine where the projectile is going to land, where's the trajectory. Okay. All right. So now what we're going to do is we're going to build our two projects, and you're going to practice with the trajectory. So you're going to I'm going to give you a couple challenges so that you can build a couple little projects, and then you can practice trying to learn about launch angle and force. Okay, the first one we're going to build is a catapult. Now, you're going to need 7 regular craft sticks, the regular size ones, and then 2 jumbo, and I'm going to show you those. You'll need 3 rubber bands. I'm using a water bottle lid. You'll need glue. I'm using pom-poms as my projectile, but you could use a balled up piece of paper. And I'm also using a Dixie cup to kind of as my hoop that I want the projectile to land in. Okay. Now, if you go through my thing, I'm going to show you step by step how to do it, but I'm actually just going to walk you through it now. So I'm going to quit sharing, and we're going to build it together. So I have my 7 regular craft sticks here. I actually think I have 8, so I'll put one back. Okay. I have two of my jumbos. So you notice they're bigger. Okay. I have my rubber bands right here. I have 3 of them. And I have my bottle cap. All right. So step 1 is I'm going to cut some notches in my large popsicle sticks. These are what they look like. And I just use scissors. So you might need to get some help with an adult to do that. So I'm going to get 2 that I have not notched yet. And I'm going to take my scissors. I'm going to use my big orange ones. And I don't want to do it clear at the end here. I want to come in an inch or so. And I want to cut a little notch so that my rubber band is going to sit in that notch. Okay, there we go. Doesn't have to be real big. And then I'm going to cut a notch on the other side as well. Okay. Now I want the notches on the other side to be close, so I'm going to kind of help measure that. And I'm going to put notches in this one as well. Little notch. And then I want to do the other side. Little notch. I did better on this one, I think, than I did the first one. All right. So I got my little notches in there. Okay. Now I'm just going to put these to the side once I've got them notched. And I'm going to pick up my 7 regular craft sticks. And I'm going to stack them on top of each other to make a pile. Okay, and I want them to be even. Okay, then I'm going to take a rubber band and I'm going to twist it tightly around all of them so that it holds all 7 of these craft sticks nice and tight together. Okay, just on one end and not all the way to the end. Give it about an inch or so. Okay. Now, the other end is not rubber band yet, but I'm going to. But before I rubber band that in, I'm going to take my 1 jumbo craft stick and I'm going to slide it between the bottom 2 there. Because if I rubber band this, it's going to be really tight and it's going to be hard to get in there because this holds, these stack holds, gives pressure. So I want to make sure I put this in first. Then I'm going to take my other rubber band here. And I am going to rubber band the other side again, nice and tight, so that they stay together really good. Okay? Now, just like that. Now, what I'm going to do now is I'm going to take my other craft stick I have created here, and the end opposite the notches down here, I'm going to glue on my bottle cap. Now, I'm using hot glue, but you could use Elmer's glue or glue dots. Just make sure that your glue dries so that you're not launching your lid. Okay? So then I'm going to put my bottle cap on there so it's nice and secure. It's not going to fall off. Now, what I want to do is I want to take my popsicle stick and put it on top of the pile where the 2 notched ends are together. Then I'm going to take another rubber band and I'm going to rubber band where those notches are. Now this one I'm not going to quite do as tight. I need a little bit of room there. And then I'm going to slide my stack in the middle. Okay. Now when I bend this, you see how I'm bending this stick? When I let go, it snaps up. That creates the torsion to launch something. So now I can wad up my paper or my piece of paper, or I'm using a little pom-pom and I'm putting it in there. And so when I pull it back and I let go, it launches my pom-pom and into the air. So however much force I need, remember that if I need a lot of force, I'm going to put it all the way back. If I don't need as much force, I'm just going to pull back a little bit. Okay, and your challenge, build the catapult, get your projectile, put it in there, and then I want you to put the Dixie cup a little ways away, and I want you to try to flip the projectile, launch the projectile, and have it land inside the cup. Okay? Now, if you can do that, you're better than me. It took me like 20 minutes to get mine in there, but it was a lot of fun trying to get it in there. And you get a lot of practice understanding about force and your angle here, how much space you need for the force. Okay? Challenge number 1, catapult. All right, challenge number 2. Actually, the idea came from my Tinker zine. Loved the idea, loved the magazine. I am going to build a bow and arrow, which also runs on the same kind of object of bending. And we're going to be using dowel rods. So I have some dowel rods. I bought this set at Walmart, pretty cheap. I think it was like $3 for, I think there were 16 in here. I do a lot of things with dowel rods, so I buy these a lot. So I'm going to use 2 dowel rods. I'm going to use some duct tape. Now I have pink duct tape, but you can use any color. It doesn't make any difference. And string. So I'm just using string. Now I've got my string off of a ball that looks like this, but you could use any kind of string, or you could even use fishing line if you want. Okay. So the first thing I do is I take my 2 dowel rods, okay, and I'm going to put them together, and I'm going to overlap them there about 4 inches or so. And I'm going to use a real big piece of duct tape, and I'm going to start at one end, and I'm going to fold it over, and I want to tape this really well. Wrap it around the whole way, make it nice and tight so that these 2 dowel rods stay together there. That's going to be our joint, and I want my joint to be completely secure. You might want to have an adult kind of help you here, and I tried to go all the way and cover up the end, getting it nice and tight. Okay, so that's my joint. Okay, and here's the rest of my dowel rod. Okay. Now, I took another piece of duct tape, and I just cut it lengthwise because I don't need this one really wide. Okay, and I'm going to take it and I'm going to wrap it around one end of my dowel rod. Now, notice I didn't go all the way to the end. I left a little piece there, and all I'm going to do is just keep wrapping right over top, because what I want to do is make this a little section of the dowel rod a little thicker, so that when I put my string on there, it won't slide down my dowel rod. Okay, so I'm just creating that thickness there. Okay, and mine's not perfect, but there it is. Now remember, I left a little end, and now my string's going to sit there and it won't slide down over top. Okay, now I'm going to do the same thing on the other end. Okay, here's my duct tape. Again, I'm not going to be right at the end. I'm going to go right before the end. I mean, about an inch or so away. And then I'm just going to wrap it, keep wrapping it around so I can make this end also nice and thick. Okay. Okay. There we go. All right. So both of my ends are now dowel rod, or now duct taped together, or duct tape to make thicker, and my joint is ready. Okay, now I cut a piece of string. You're going to want to measure a piece and then cut, but you're going to have to experiment on this. This one you may have to cut 3 or 4 pieces of string to get it right. But I'm going to take my string and I'm going to tie a slip knot. To make a slip knot, I put it around my fingers. Okay. Then I take the string back here and my working string and pull it through, and then I get a slip knot. So this slides. See, so it slides up, and then when I can pull this, it slides down. So it gets bigger and smaller. And I want a slip knot because when I put it on this end, I want to tighten it up so that it will be nice and snug on there. So I put it on that end, tighten it up, so I have a nice slip knot on there. Okay. Now my other end, see, I made my string a little bigger than the other end straight, but I probably will need to make some adjustments on it. But I'm going to start there, and I'm going to put a slip knot on this end as well. Reach through, pull, so I have a slip knot. Now, notice that my string is shorter than my dowel rod, which is what I want. Because what I need to do is I need to very carefully bend my dowel rod so that my string goes on there. Okay, well that is way, way, way too long. So I want to make my slip knot better. So I'm going to tie it down a little further so that it makes my string nice and tight and taut. Because I want the dowel rods to be bent. Remember, because it's that bend, that one might be too short. It's the bend in the dowel rod that creates that torsion, that force that you need. Okay? So maybe I help if I put this down. Put my string in there. Ooh, slip knot. Okay. Now I'm going to bend, and I don't want to bend too much, so I may have to pull this up a little bit to get this in, because I don't want to break my dowel rod, and I just want to slide it on. Now, tighten that up, and now here I have nice and tight. See how my dowel rod is bent? But if you bend it too much, you're going to break it, so you don't want to bend it too much, but you want it to be on there tight. So I used my 2 slip knots so that I could get that on there. Now, my bow is done. So if you want to cut your little excess strings off here, you can do that. You don't want to, it won't make any difference. You don't have to. Okay. Now, I've got to launch an arrow. Okay. So to make an arrow, we want to use very safe arrows. Okay. And I want a lot of them, so I want to make them cheap. So I just got a big bag of straws. Now, unfortunately, my straws are the bendy straws, and this bendy straw I don't like. So I'm going to take and I'm going to cut that bendy part off. I don't want it. Okay. Now this is going to be my shaft of my arrow, and I'm going to cut a slit in it. So I'm going to go sideways and create a little slit in the bottom of my arrow, and that's going to be what slides on the string. So that slit there is going to go and keep my arrow on here. Okay. So now I need something on this end. So I decided I didn't want anybody to get hurt. So I'm using a marshmallow. So I'm taking my marshmallow and I'm sliding it on the end of my arrow. And now all I have to do, might want to get my marshmallow on there a little better, is pull back and launch, and my arrow flies. And this is where I'm going to work with my trajectory, okay? Or, my launch angle. If I go like this, it's going to go up real high and then come down real quick. If I go launch real low, it's going to hit real close. So I want to get a nice launch angle going between the ground here. I'm going to get a launch angle and then shoot my arrow, okay? All right, so you have to think about those questions I said. How heavy is your projectile? How much force you need? That determines how much of this you need to pull to bend. And your launch angle will help you to know the distance or your range. So enjoy your bow and arrow. Enjoy your catapult. Also, on my slides, which I'm going to go back to my slides here real quick, I did go step by step through building the catapult. I included all kinds of pictures on there. You can even see my hands on the bow and arrow part so that you can see how to build it. Then launch. There it is. And now I'm going on to the bow and arrow. And I go straight through. There's your materials. Step 1 is your dowels. Do your tape. Then you're going to tape the ends there. Then you're going to make your slip knot. Then you're going to slide it on one end. Then you're going to bend it and slide it on the other end. I need to put a picture in there. And then you're going to make your arrow there. Put your marshmallow. And then you have your bow and arrow you can shoot. Do not shoot this bow and arrow at a person. Okay, always remain safe and never shoot a projectile at a person. Okay, practice and see if you can learn a little bit more about how much force you need and your launch angle to get the arrow exactly where you want it. So I also put in here a target for you. So if you print out the target and put it on the wall, you can launch your arrow and see if you can do 5 launches to see if you can get as many points as possible. Now on this one, 10 is the highest. You can get it right there in the center. If you do that 5 times, you get a high score of 50 points. That's the highest you can go. So practice and see if you can get what score you can get closest to 50. Okay, so practice, do 5 attempts, 10 points each attempt. So that would be the highest possible score of 50. And learn a little bit about trajectory and launch angles and those things. So in the presentation, I included all that. So make sure that you look at that, or you can watch the video again to see how to build your bow and arrow and your catapult. All right. Again, if you're interested in the ballista, you have to go to Tinker Crate, which is from kiwico.com, and look at their crates. So enjoyable, very enjoyable. So until next time, see ya. I'll see if I can come up with some other ideas for you for this summer. And if you create something, or make your bow and arrow, or you make your catapult, send me a picture, send me a video, show me how many points you got. I'd love to see what you can create. Or can you create something else? Can you create something better? And if so, send me a picture. Okay, send me a video. Again, my email is M as in Margie, Suder, S-U-D-E-R, at k12.wv.us. Can't wait to see what you've done. Talk to you later, guys. Bye.